Simple Network Management Protocol, SNMP, is a protocol that we can utilize to gather statistical information about the health of our routers and switches and firewalls within our organization. So we can run SNMP on our devices, and our devices can collect information about themselves. Where is this information going to be stored? Well, the information is going to be stored within the management information base on the agent. So the agent is that router, is that switch, is that firewall, and they have this management information base, the MIB, a database that's going to keep all the statistical information that it's collecting about itself. For example, CPU utilization, memory utilization, interfaces changing their status. And that information is stored in there until our network management server, so the manager or the management station, pulls that information from the agent. So it goes and grabs it. However, we can set up our routers and switches and firewalls to send traps or inform messages to that NMS. So instead of waiting for the NMS to grab the information, we might have our devices set up to automatically send a message, that notification known as a trap or inform, to the NMS. What is the difference between a trap and an inform? Well, a trap is unidirectional in nature. What does that mean? Well, the agent simply sends that trap to the NMS. That's it. It just goes to the NMS. Is there any verification that the NMS received that trap? Nope. There's no verification whatsoever. That's why it's called unidirectional. So the agent's done its job. However, if the NMS didn't get that information, then that's no good to us. So the inform instead is classified as being bidirectional. It's bidirectional because the SNMP agent will send the inform message that something has occurred to the NMS, and it's going to wait for an acknowledgement from the NMS in regards to that inform. If it does not receive an acknowledgement, what's it going to do? It's going to send the inform again. It's going to keep sending that information until it gets the acknowledgement from the NMS. There are various recommendations for SNMP. For example, you can, as you see, pull and grab information from the agent. However, you can also change information on the agent as well from the NMS. So unless it's absolutely necessary for the NMS to change information on the agent, then you should avoid implementing that feature. You should restrict access to only read-only, meaning that the NMS can grab the information from the MIB for analysis purposes. It can't change anything. You also want to set up views, and views will give you the ability to restrict what the manager has the ability to access and grab from the management information base, giving you better security. Also, you'll want to control which network management stations can pull the device, can grab that information from the MIB, and you can do so by setting up access control lists. Also, if you haven't implemented SNMP version 3, and you haven't even considered it yet, you might want to start looking into SNMP version 3. Why? Because it gives you better authentication, it adds support for encryption, and it's going to ensure that the data being exchanged between the agent and the network management station has been modified in transit, so its integrity has been maintained. Now, there's different versions of SNMP. SNMP version 1, version 2, there's also version 3. What's the difference between all of them? Well, let's start off with SNMP version 1. SNMP version 1 gave us 5 basic message types. We had the GET request. So get this particular object from the management information base. And then the GET next request, get this next piece of information from the management information base. There was also the SET request, whereby you could modify the values in the MIB. And as I was saying earlier, you want to avoid this unless you absolutely must have the NMS modify those values. If it's not a necessary process, don't allow this to occur. So only allow read-only access to the MIB, not read-write access to the MIB from the network management station. Then you have your GET response, where the response to the request is sent to the manager. And then you have your trap, whereby we have that alarm that goes off. It triggers our device to send right away that message to the NMS instead of waiting for the next polling interval. So those were the 5 basic message types. And these 5 basic message types are also in SNMP version 2. However, with SNMP version 2, we also have the addition of the get bulk request. So instead of grabbing one object at a time from the MIB, we can grab a whole bunch at the exact same time. And then we also have the inform messages that have been added as well in this particular case. Now, SNMP version 2 is actually known as SNMP version 2C because it still relies on community strings. There was a version of SNMP version 2 before version 2C that didn't use community strings, but it was relatively complicated. People didn't adopt it, and as a result, it was put to the wayside, and they went back to using community strings instead of having enhanced authentication encryption. But now, it is very important that we have enhanced authentication encryption, so that's where SNMP version 3 comes into play. It's going to give us heightened authentication using hashing algorithms. We are going to have encryption now through various encryption algorithms. It's going to maintain the integrity of our data while it's in transit. We'll also be able to add authorization features and access control features. So there are different security models available with SNMP. And you'll notice that the security models really only come in 3 different flavors. We have no auth, no priv. We have auth, no priv. And we have auth priv. So depending on the level of security you want will determine which security model you are going to implement. One thing I want to point out here is that the no auth, no priv security model is available with SNMP version 1, version 2C, as well as version 3. But what is the difference when you look at version 1, version 2C, and version 3? Well, it's the type of authentication that's in place. Now, I want you to realize that even though it says no auth, no auth, no auth, it does not mean no authentication. You can have authentication, and it's important that you have authentication, and that authentication is going to be done with community strings for version 1 and version 2C. What is a community string? Well, a community string is just a password. That's all it is. The problem, though, with version 1 and version 2C is that the community strings are sent in clear text. Therefore, it's easily readable by a man-in-the-middle capture. And as a result, we do have a vulnerability at this point, and that could be taken advantage of, and our SNMP implementation could be breached. Now, no priv definitely means no encryption. That's what it means, no encryption. When you go down here to SNMP version 3, though, you'll see that we no longer use community strings for the authentication process. We are going to use username when it says no auth. So no auth, no priv for version 3 means username and no encryption. Now, when we get up further into the security models for version 3, you'll see that we have auth, no priv. Now, auth means we are going to use a heightened type of authentication. What do I mean by heightened type? Well, more advanced. We're going to use hashing algorithms instead of just simple usernames that are passed in plain text. We're going to use MD5 or SHA as our hashing algorithm. However, we still don't have encryption for that data that's going to be passed back and forth between the SNMP agent and the SNMP manager. So if we want complete and other security, we're going to use authentication with MD5 or SHA, and we're going to implement encryption using encryption algorithms such as DES, triple DES, or AES. And in order to accomplish that, we're going to need SNMP version 3 with the auth priv security model in place.